This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers, retirees, students, and other not-so-nefarious characters who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will continue work on fabricating the breadboard function's power distribution strips. What I'm doing here is marking off approximately 1.5 inches on this FR4 board to be used as an insulator. Since I removed the foam-based double-sided stickum goo, I'm going to replace it with FR4 insulation. This board is the stuff used in quality printed circuit cards, except it's got no copper on it. Unclad. Very good insulator. It's relatively easy to work, but it's quite flexible. It will become more rigid when it's epoxy glued to the power strip. Alright, I'm going to mark off the scribing tool scratches and just see how much of this I need and mark the maximum length off. And now we need to start sawing. This large hacksaw is not the best idea to cut this stuff with. I've tried many different ways to cut printed circuit board material. Razor saws, keyhole saws are all good for short lengths of the material, but have their drawbacks. Smaller hacksaw works really well, but this big one does not. It's catching on the board, and the board is just too flexible for it. If you notice, I'm using paper strips to avoid abrasion to the board. And now I'm just going to cut off the strip at length. Again, it's awfully wobbly, and hopefully the board will live through this. Once having done this, the next step is to dress up the board, but I need to, before starting this, I need to clean up the file with a wire brush. I try to do this both before and after using the file when I remember, particularly when I'm filing a really soft material like this. And the idea is to straighten up and to round off the edges. Getting back to ways of cutting this stuff, I tried a rotary tool cutting wheel, and that works. It's a quick way of cutting the stuff, but it's difficult to control. I've heard that using a sheet metal shears is a good way to cut this stuff. Alright, now let's just get the rough edges out, and we're almost done with this. Okay, now I've got a strip of proper width. Now that I've got a strip of the proper width, I need to mark off the required lengths to the left and right of the soldered wires. These are actually a little different for each side. I'm using an ultrafine Sharpie, and I'm carefully marking off which one is the right and presumably which one is the left. These don't have to be super accurate, but I'll bet you I'm going to forget what right means and what left means. Anyhow, we need to C-clamp this to the table using a piece of paper to avoid abrading the material. This is a small hacksaw I'm using. It's very effective for this kind of material. Unfortunately, because of its limited reach, you can't cut very long pieces with it. But it cuts straight and quick. Now we need to cut the other piece off. They made this saw with a longer reach of about 3 or 4 more inches. It would be really great. We've got to clean up the edges on these things, straighten them out, and get rid of the sharp points and so on. And if you noticed, I used a wire brush to clean up the file first. One has to decide. You either go out and buy a wire brush or buy files by the dozens. And here we are, ready for gluing. Now that we've got the major insulation FR4 board cut to size, next job is put some epoxy glue on the back of the power distribution strips. And after cleaning off the FR4 board with alcohol, put it on the insulating board. This is Loctite 5-minute epoxy glue, meaning it'll be fully set in about a day or two. As with most stuff, just because it says 5 minutes doesn't really mean very much. It becomes unworkable after 5 minutes, is I guess what they mean. It starts setting up. Now we're using clamps here. Let's hold this thing in place. I'm using different types of clamps because that's what I have. And now we're doing the other side. First, having cleaned it off with isopropyl, we're now applying a layer of epoxy glue to the power distribution strips and then to the previously cleaned insulating board. I don't really know if it's necessary to apply glue to both sides. I do it anyway. More or less proper size. You know the old saying, measure twice, cut thrice. Okay, now this is ready to sit around for about a day, and we'll be ready to work further after that. Now, having cleverly masked the mounting holes after having glued the insulation background, I'm now using a center punch to punch some holes so that I can drill out the FR4 board, which is now glued to the strip. I've got to clamp the strip to the table. Again, I'm using a piece of wood here to avoid damaging the strip, and another clamp near where I'm about to drill to avoid delaminating the insulation again. And this is pretty much okay. All right, now we've got the holes. I'm using Mighty Putty as hawked by the late great Billy Mays, and use it as a insulator and strain relief for the previously soldered wires. Billy Mays being one of the more notable hawkers, second only to Pope Peel and his pocket fisherman and set it and forget it rotisserie. Anyway, I'm going to be using this stuff to fashion insulation and strain relief for the wires. One needs to continuously knead this and roll it until it gets to a uniform color, kind of a greenish gray, which is now. And now it is kind of like putty and can be shaped. And we want to press this deep into the wires and covering up the solder connections, and high enough so that it's going to provide strain relief for the wires. We want a bond between the epoxy putty and the wire insulation up high enough so that it's way beyond any interface between copper wire and solder, so these wires are not going to be breaking off, which occasionally happens even with flexible wires. When you solder them directly without any strain relief, they'll bend exactly where the solder ends off and there's naked copper, and all of this is underneath the insulation. Bend it back and forth and they break, and sometimes they break in ways that are not obvious, and you get intermittent connections. Anyhow, this is designed to prevent that sort of thing. It shapes reasonably well with a flexible putty knife, and it's just a matter of keeping at it. Now the other side, which is the side opposite to the solder, is a little easier to do. Again, the putty needs to be done high up on the wire and pressed into it to act as strain relief. It's not all that difficult, you just need to keep at it. This is not half bad here. I'm going to do a little trimming on the edges. For appearance's sake, really. Cut the edges off. And it's overall a fairly good. It's a non-professional job. In this video, I cut Unclad FR4 board to size and finished off the pieces, cleaned and glued the board to the back of the power distribution strips, used epoxy putty to fashion strain relief and insulation for the soldered wires, and drilled mounting holes through the glued board. In the next video, we will be mounting the power distribution strip to the enclosure and connecting the wires to the corresponding binding posts. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. It's not all that difficult, and I promise to read it. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, vector graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.